everyone. So today we're going to talk about some chemistry things. So you all know about matter, and you know that everything in the world's made of matter, so I'll just write the word matter up here. So what's matter made of? Does anyone know? Yeah, Kane?
Matter is made out of three things: a solid, a liquid, or a gas.
Very good.
Aren't those the three forms of matter?
They're the forms of matter, so what do you think matter might be made of?
Quarks and other tiny bits of things.
Like
Yeah, so you could
atoms.
say like atoms, yeah, like atoms. So atoms and atoms join together to make molecules. So today we're going to look at some ways that matter does change. So just like Kane was saying, how you go from solids to liquids to gases. So here, I've got some ice that looks like it started to melt. It's not very exciting. You've all seen ice before.
Ice.
And a cup of water. Okay, and then there's some water in there. You can see there's a little bit I can spit out probably. We can make a mess. There's some water. Alright, so if I look at water, you can see that it's a solid. How do I turn it into a liquid?
You apply heat.
That's right, you apply heat. And what's it called if I heat a solid into a liquid?
Melting.
Melting? Okay, and can I put a liquid back into a solid?
Yep.
Yes.
You have to freeze it.
Freeze it, so you've got to remove heat, don't you?
Yeah, and if you add more heat, you can turn water into a gas, which is called evaporation.
That's right, and so that would make it into steam. Yeah? So I've got some little bits here of water molecules. So these are ones that I made earlier. So these are just water molecules. So what's the chemical formula for water? Okay.
2 hydrogen, 1 oxygen.
Yep, so what's it called?
H2O.
Yeah, so you write it as H2O. So these are all H2O. So there's the two H's and there's the O. So when I've got a solid, what happens is these molecules are all kind of packed together pretty tightly. And that's in all solids, not just water. All solids, the molecules are packed together tightly. And when they're in that thing, they're moving a little bit because matter always moves.
Unless they hit absolute zero.
That's right, unless they hit absolute zero, in which case, but we've never actually got to absolute zero, get very close to it. When you go to a liquid, they're going to spread out a bit and they're a little bit more random and they'll still be moving, that's right, like that. So, in a liquid, like when you get to a gas, they totally spread apart. Now,
One might be all the way over
that's
there.
right, one all over there, and they're also moving really quickly in a gas because they've got lots of heat, and heat is energy, so they've got lots of energy to wiggle and twist and jump and move around or fall off the table. So,
That one was really...
when we've got things like that, can you see that it doesn't matter if this is packed in close together or spread far apart, that we've still lost his hydrogen. They're still just water molecules. We haven't actually changed them. Okay, so that's called a physical change if we move from solid to liquid. It's just a physical change.
Yep.
And the thing about a physical change is we can reverse it. Okay, so I can turn that ice into water. I can turn that water into ice.
Then,
And
if
you
you can reverse a physical change, do you think doctors will ever be able to completely reverse the aging process?
No, because I think that's a chemical change.
Do you think it's possible that scientists will discover a way to have 1 hydrogen and 2 oxygens?
No.
Yeah. Let's do this. So this is just salt.
Yeah.
This is just water. If I just put, I don't even need a spoon. If I just put the salt in the water, what am I making?
Salt water.
Salt water.
Which is hard to heat up.
But,
Oh, the freezing point is low.
yeah, the freezing point's now lower. So what has happened to the salt in there, hopefully?
It's
dissolved.
It's
Okay.
dissolved.
So do we think that's a physical process?
No, I
You don't think it is? Do you think it's still salt in there? It's still salt and you
Yeah.
haven't changed it? It's
Yeah,
just
but
salty water?
I just think,
Yeah.
yeah. I think it's just a chemical change.
Yes, because you
I
can
think it's a
reverse.
physical change.
You can
Yeah,
reverse it by
I can
heating
reverse
it
it. I was
up.
just about to say, can we reverse that? Can I get that salt back out of there?
Yes.
And how would I reverse that?
You
By
can heat it up.
evaporating the water.
Yeah, if I evaporate that water really carefully, so I'd have to boil it, wouldn't I? If I boiled the water, you'd probably get the salt left on the bottom. So that's definitely a physical change because it's just easy to reverse.
I want to make some salt water.
Although
I mean some sea salt.
Some sea salt. Alright, let's look at something now. Okay, I've just got some matches.
Can I light it?
No, I'm going to light it.
Aww.
If I can.
There you go.
What's on the tip of a match?
That's called the
Phosphorus.
safety flame.
It is, oh,
No,
yeah.
a safety flame's on a Bunsen burner.
On a Bunsen burner, not so much on a match. So, what was on the tip of that, the red stuff?
Phosphorus.
So it's phosphorus. Okay, so I'm burning that. Do you think that's a physical change?
No, that would be a chemical change.
That would be I can't reverse that, can I? Can I unburn that?
Not unless you can turn time back.
No, I can't probably do
Tick
that
tock,
today.
tick tock, tick tock, tick tock, tick tock, tick tock.
Okay, so what we're going to do with that is I can't reverse it. So that's called a chemical change. So a chemical change is when you can't reverse it. So what's happened is that phosphorus has obviously reacted with something. So it's reacted. What do you think it reacted with?
The
The
wood.
oxygen.
The wood and the oxygen in the air, I'd say. And so
The,
we form something different.
This is the friction to light the.
Yeah, so the friction to light it gave it enough heat for
You
it
mean
to
like
react.
conduction, convection, radiation?
Yeah, well that was just like, yeah, so that was just a friction one. And then we'll do another one. And you can tell me if you think this one is going to be a physical or a chemical change. So this is just vinegar.
Yeah.
White vinegar.
Yeah.
Out of my kitchen cupboard. And this is bicarb soda. Now bicarb soda is sometimes called baking soda.
Oh yes.
Okay, it's you can use this to make cakes rise and bubble and stuff. So if I put some of this in the vinegar,
It's gonna make a chemical change. If
think
I
that's
were
a
you, like,
chemical change?
and if I were you, I would get that off your table.
Oh no, it's fine. Because do you know what it's making?
A
It's
chemical
making-
reaction.
It's making a
Carbon
gas, isn't it?
dioxide.
Yeah, it's carbon dioxide gas is what it's making. So it's making a gas and we can see. And so when we say, well, was that a chemical or a physical change? That's made something completely different. It's made a gas and I can see that gas coming off.
So would the oxygen come from the vinegar or just the air?
Let's make more.
Oh, no, it would come from the vinegar.
Let's make more.
Let's make more. All right, put a little bit more in and see how that goes. Yeah, that'll work.
Now more baking soda.
More baking soda.
Bicarbs.
Just put the whole bunch in there.
Yeah. So, do you think I can reverse this? Do you think I can get...
No,
You know, if I boiled that, like I did with salt water, if I boiled that, would I get my bicarb soda back and would I get... No?
No. Busy.
So that's definitely a chemical change, isn't it?
Does that chemical reaction produce heat?
Feel it and see. So sometimes you get some chemical reactions produce heat, some chemical reactions
that I
actually
can
get
feel.
colder. Does it
That's
feel,
going colder.
does it feel colder or hotter?
Well, let's see. I'd say it's about the same.
Yeah, I think it might be about the same. It's probably not producing a huge amount. Not everything does, but
That's
a
a lot of
we
vinegar.
can put a bit more in, see how it goes.
Have it
So can you
go
think of
over
any
onto
other...
the
Oh, on the
table.
table. Can you think of any other... Oh,
Yay! I want to see that happen. Now let's put some ice in there and see what happens.
Wait, alright,
So,
so, some ice in, so what happens is it's going to make it colder.
So let's see.
Add some vinegar?
Soda.
Not too much.
Add to the ice?
So
It
let's
does nothing!
Bicarb soda
I feel
and
ripped
white
off.
vinegar.
And ice.
What's vinegar made of? What's
Vinegar is
the-
acetic acid, so it's made of carbon and hydrogen and oxygen.
Okay. So
I have broken your circle.
So we've just decided we really can't reverse that. We cannot get
Yeah.
all of that back. Put some water in. It's probably not going to do much to it though. It'll just dilute it.
so then
So can you think of anything else? Any other examples of a chemical reaction? At home? What would happen if I cooked an egg? Would that be a chemical or a physical change?
that would
That would be a
Yeah.
physical change.
Because I can't uncook an egg, can I? What about like a piece of steak? If I cooked that,
That's a chemical
That's a
change.
chemical
That's
that's a chemical change.
As is making a cup of tea, isn't it? Or putting milk into a cup of tea.
Milk into a cup of tea, do you think?
Yes.
I don't know if it is.
Because there's a difference between putting milk into a cup of tea and putting tea into a cup of milk. It's just a difference in how the tannins break down.
Oh, okay, alright, so the tannin in the tea. So, what about making a cake? What do you make a cake? Is that going to be a physical
That's
change?
going to be a chemical change.
It's gonna be a chemical.
And do you know what happens? You know how you put this in cake, or you put baking powder, or you use
Yeast
something?
or something.
And so what happens is you've got really, really sticky cake batter. And what that does is all that gas that's being made, the carbon dioxide, that's what gets trapped in the batter, and that's what makes the cakes rise. And sometimes when you cut into cakes, you can actually see the little bubbles in them. That's from the baking soda reacting with everything else in there and making a chemical reaction. So not everything that's a chemical reaction needs to be actual chemicals.
Yeah.
It can be everyday things like cooking an egg or making a cake.